Looks like we're live. Hello everyone and welcome to yet another recreational programming session with Mr. Azuzin. Let's make a little bit of an announcement and officially start the stream as usual, live on Twitch with a red circle, of course. And what are we doing today on Twitch at television website? Today we are implementing AI paper in C. How about that? Finally. So I'm going to give the link to twitch.tv/studying, the place where we're doing all of that. And I'm going to ping everyone who's interested in being pinged. And there we go. The stream has officially started. So a couple of streams ago, we were implementing k-means clustering algorithm, right? So, like I'm gonna put the link to the playlist in the description as usual. And k-means clustering is a very cool algorithm. I really enjoyed implementing it. And I was implementing it because I thought it is used in this cool paper that I wanted to implement for quite some time. Right, but then I looked closer into the abstract of this paper, and apparently it uses k-nearest neighbor rather than k-means clustering. So for the past two streams, I've been doing the wrong thing. All right, but I mean, implementing k-means clustering was actually kind of fun, right? So I do not regret that, and I'll still recommend to watch those streams. But that means that we're going to be doing a completely different thing today, right? So we're going to be doing a completely different thing. Right, so essentially, what is a k-nearest neighbor classifier? It's rather an interesting thing. Right, so let's actually Google it up. And in fact, it is simpler. It is in fact simpler than k-means clustering, right? It is way simpler. So essentially, what do you have? Imagine that you have a bunch of like points, right? So some sort of a data set, and each point has a class, right? So on this sort of image, the class is denoted by the shape of the point, right? So we have squares and we have triangles. So, and essentially you have a new point, and your goal is to classify that point, assign one of the labels, right? So you have the circle, which is unclassified. You need to decide, so what is it going to be? Is it going to be a square or is it going to be a triangle? So the point of k nearest neighbor classifier is to basically consider k nearest neighbors, right? For example, we can consider 3 nearest neighbor and assign a class to this point that is most frequent among these k nearest neighbors, right? If you pick a k3, the class is going to be triangle. But if you pick k5, the class is going to be square, right? Because it's the most frequent one. That is it! That is freaking it! Mathematicians are at it again, seriously, right? Given a fancy name to a very stupid, dumb idea, of course, it has to be k-nearest neighbor classifier. Fucking, yeah, it's literally that. So, and essentially, it's more boring than k-means clustering. Honestly, k-means clustering is way cooler, but I'm gonna give the link to this thing in the description as well. So what's the idea of this paper? The idea of this paper is to classify documents, right? Classify documents. Not only that, but they wanted to demonstrate that a very dumb, like absolutely fucking dumb approach is on par with the state-of-the-art AI language models and shit like that, right? They wanted to demonstrate that, and as far as I can understand, they managed to do that, right? So essentially, you have, data set of text, right? So some sort of like a bunch of text, and each individual piece of text has a class or a label associated with it, right? So, and your goal is to, given another new text that you've never seen before, assign one of the classes, basically k-nearest neighbors, right? So, but the way they compute the distances, right, for these data sets, for these data points, is actually rather interesting, right? So you have a text, and you need to compute like how close that text is to a certain thing, right? So let's actually go to the formula. So this is like the only thing we need in here. Actually, the only thing we need in here is this formula, Right. So the distance is so-called normalized compressed distance. Normalized compressed distance. And x and y are the texts, right? So you have two texts, and you compute normalized compressed distance, and you are doing k nearest neighbor on that normalized compressed distance. So how you compute that? You concatenate x and y, and you compress the concatenation of x and y with gzip, literally with gzip. And you take a length of that. So this function c is basically compressing the input and taking the length of that. That is it. Then you subtract a minimum between c of x and c of y. So you take the concatenation of them and subtract the minimum of them separately. And then divide it by the maximum of them separately. That's it. That is fucking it. And then you do k nearest neighbor, and that classifies very accurately your text. And it fucking works. They demonstrated that this shit actually works. The question is, why the fuck does it even work? It's really bizarre. It's really bizarre. Why the fuck something like that would even work? So essentially, C is not like a random choice. Like using gzip is not like a random idea that they got out of nowhere. It's an approximation. It's an approximation of Kolmogorov's complexity. Right. So originally they would like to use Kolmogorov's complexity instead of the length of the compression, but they couldn't because, as far as I can understand, computing Kolmogorov's complexity over text is an NP hard problem. So they couldn't do that. And what is a Kolmogorov's complexity? This is a concept that I never heard before reading this paper, because I am that ignorant, I am that uneducated. My university was shit. I'm really sorry. It's kind of embarrassing for a Russian to not know what is Kolmogorov complexity. But anyway, let's put that aside. So let's actually Google up. It's a really fascinating concept, actually. Kolmogorov complexity. So it's, let's take a look at the definition. Kolmogorov complexity of an object. Such a piece of text is the length of the shortest computer program, such as piece of text is the length of the shortest computer program that produces the object as the output. So Kolmogorov's complexity is the length of the smallest program that produces the text. Right. So, and as far as I know, finding this kind of thing automatically is like NP hard problem. Like that's why they couldn't do that. But that starts to make sense. That starts to make sense because, right, look. So essentially, you can view compression algorithm as an attempt to produce a program that, while evaluating, produces the original text. You can view a compressed text as a program and uncompressor as the interpreter that then produces the original text. You can actually view that, right? And since gzip is not like perfect, right? It's not going to be the Kolmogorov's complexity. It's going to be approximation of Kolmogorov's complexity, and it's going to be something that is super close to Kolmogorov's complexity. Maybe not super close, but pretty close, right? So you can use it as an approximation. And because of that, like the better compression algorithm you use, the better overall approach this approach is going to be. So it's not like necessarily about gzip. Maybe in the future, people will find a different, like a better compression algorithm, and you can just plug it in here, it will still work, and it will work better. Right, and why does it even work? I didn't fully read the paper. The only part I read is the, essentially, I think up until the experiments, right? So I basically read like all of these things up until experiments, and specifically our approach, right? This section, our approach, is the most interesting section. So why does it work? So I think it has something to do with maybe X and Y having common parts. You know what I mean? You know what I mean? So if X and Y have something in common, the concatenation of them is going to be way shorter if they have nothing in common. You know what I mean? Right. So essentially, if they are very, very close to each other, the concatenation, the compression of the concatenation is going to be unexpectedly shorter, which overall may result in a shorter length. This is my hypothesis. I didn't fully read it, right, but this is how I probably understand it. Right, so does it make sense? Maybe it does make sense, but yeah. So I think I will need to put the Kolmogorov's complexity to the description as well. And here is an interesting thing. You can think about the Kolmogorov's complexity as a compression algorithm. In fact, Kolmogorov's complexity is the best compression that you can ever have. Right. If you will have a program that computes somehow Kolmogorov's complexity, you have the ideal compression algorithm. Perfect compression algorithm. Which is fascinating, isn't it? Right? And yet again, this kind of demonstrates somehow connection, this weird connection between compression algorithms and AI. Right. So, because to produce a very good compression, for example, of a text, you need to understand it. I don't know, so like the better you understand the text, the better compression algorithm you can produce, which kind of goes into the area of AI and stuff like that. So I don't know. But anyway, what I want you to do, I want you to basically implement that, right? So I want you to implement that. They already have implementation. So interestingly enough, they put the entire source code of the algorithm that they use in the paper, and they formatted it horribly, fucking horribly, or probably intentionally, right? So freaking AI scientists, right? So here's our entire code. Enjoy, right? And some of these things, like, it's completely fucking unreadable. It's just like but in any case, it's very simple. But I would like to implement it purely in C, right? So I'd like to implement it purely in C, right? And see how it will go. They also talk about the data sets that they used. Right, so for example, they used a very diverse set of data sets. So for example, AG News, right, it basically data set of 120,000 of article titles and descriptions. They didn't take like the full articles, they only took titles and descriptions, right? 120,000 for the training. Right, and for the test, the dataset has 7,600, right? And it has only 4 classes. Maybe we're gonna just take this dataset, right? So this dataset, and we'll try to replicate the algorithm on it and see how well it classifies these 7,000 test things among the four classes and stuff like that. So yeah, that's basically the plan, the idea for today's stream, right? So we'll see how it goes. Alright, so let's go ahead and try to implement these scheiße. So we'll probably need to get these datasets somehow. So as far as I know, it's like all of these datasets are like open source and publicly available. So we can Google up AG News dataset. So I remember that AG News specifically was somewhere on GitHub. So there's of course Hugging Face and stuff like that, but I remember specifically this one was on GitHub. Right, so maybe it's that one. Maybe we have to use the Google. So this is just a topic, text classification AG News. So it's this one. It has 1 star. It's probably not the right one, but I think it's that one, isn't it? So the data. Yeah, there we go. So you have a test. Which has some stuff, right? So yeah, so here they are. So you probably have 7,000 of these mother flippers. Yeah, look at that, 7,600 exactly, exactly the amount that they listed in here. So and this is for the test, right? I think that's the set that they used. I'm pretty sure that's the set. And the training is probably, yeah, is too huge. 120,000 lines of text is impossible for the modern software to display at all. It is impossible for the modern software to display. Right, so let's go ahead and maybe just clone this thing and see how it is going to go. So I'm gonna probably doing all of that in the k-means folder, right? So even though it's not about k-means, I already kind of have like an infrastructure built in here. So I have a build system already. I have a bunch of libraries downloaded as well. So I might as well just roll with that. So why not? So let's actually go ahead and clone this thing. How many commits does it have? Does it have too many? Or only 13 commits, so that's totally fine. So let's just go ahead and do that. Easy peasy, a lemon a squeezy. So how's it going, everyone? Mein Freunde. So it's already done, so yeah. Text classification. So here's the data, and let's take a look at the train. Even Emacs is afraid of 27 megabytes of text. What the fuck with software these days? I swear to God. I mean, like, okay, so I'm gonna say yes, and there we go. See, it wasn't that hard. Okay, so this is 120,000, so that's exactly what we wanted in here. So, and this is basically CSV, and we have different classes in here. Though I'm not sure, like, what are the classes? Right, so the problem with the classes is that they're just numbers, and we don't really know what the classes are. So there's some models in here, so I'm not sure if I care about that. Kago, right, so maybe there's something in there. Class index. Where is that? 1 world, 2 sports, 3 business, Cypher. Okay, so let me see. So this is gonna be classes, right? So txt. So I'm gonna just put it in here, right? So, and I'm gonna just put this stuff in here. Yep. So maybe. Yeah, by the way, so I probably need to put that in the description, right? There we go. So classes. So did I ever create data? No, I didn't create the data. So let's actually move that stuff in there. And where's the classes? Classes. Yeah, I'm gonna put that in here. Wait, what? Okay, that was weird. So for a second, classes disappeared. I don't know what the fuck happened in here, but anyway. So I'm gonna remove this thing, and so let's actually start with maybe creating a separate file in here. Right, so I'm gonna call it knn, right? So this is gonna be knn, right? And I'm going to just do something like this. Right, I'm gonna just do something like this. There we go. Printf hello world, right? And then in here we're gonna do knn, knn. There we go. So let's see. So I'm gonna do knn just to see if it says hello world, and it in fact says hello world. So we need a way to actually, you know, parse the CSV. Parsing this CSV in particular is gonna be a little bit more difficult than the something like leaf. Right, something like leaf, where we don't really have any special characters in the fields, so we can literally just separate everything by a comma, right? So we can just do that. In this specific case, in the data, we don't, we have a lot of special stuff, right? In fact, we have a lot of special stuff. So we have quotes and stuff like that. And yeah, so what the fuck is this slashes? This data sucks. Holy shit. So is that supposed to be like a new line or something? So yeah. I should have actually like downloaded from Kaggle, but I can't download from Kaggle because it literally requires me to be logged in, and I'm not even sure if I have a Kaggle, you know, account, and I'm not creating an account on this specific setup right now, right? So I should have done that right before the stream. So yeah, I think that's their messed up new line. Oh my god, so slow. Yeah, so this is what I think so as well. So but do they have like escaped? Oh my god, they do have escaping and also scuffed new line, and also sometimes there's a double oh my god, Jesus Christ, bro. The fuck is this shit? So it would be nice maybe to download that from Kaggle, but again, like I need to register and I just like can't easily do that. So apparently we'll have to deal with this kind of shit. So it is what it is and it isn't what it isn't. So yeah. Anyways, so let's go ahead and just like try to read the entire data, right? So reading how much megabytes, like how many megabytes do we have in here? Like 28 megabytes for a computer, for a modern computer, is actually not that hard. So so it should be pretty fast. Okay, so I'm gonna do knob.h and I'm gonna just define knob implementation. There we go. And let's just go ahead and read an entire file. Right, so just read the entire file. And let's create a buffer into which we're going to be reading the contents, right? So this is going to be something like that. Right. So path, const char file path. So this is going to be data. So this is going to be the training. So we're going to load up the entire file into the memory, right? So that's what we're going to do. So this is going to be file path, and we're going to just give the pointer to the content, and if it fails, of course, we're going to just exit with non-zero exit code. And in here we can just log knob info, size of s is z bytes, right? So file path, and we're going to just take the content count. There we go. So let's compile this entire thing and see how it goes. All right. So yeah, so it read the entire thing. It read the entire thing. Look at that shit. So this is how quickly a 10 years old laptop can load 28 megabytes into memory. It just load it into memory. GitHub is incapable of displaying this file at all. It's just like less than 100 milliseconds loaded into memory and then unloaded. All right, so how are we going to be approaching this entire stuff, right? So we could spend some time maybe parsing this entire thing. We could spend some time maybe parsing this entire thing. But what if we simply just split the class and the rest of this stuff, right? Because how would I classify this entire thing? So I have a title and a description, right? If I'm gonna be gzipping, I'm probably gonna gzip concatenation of both title and description because that makes sense, right? So, and if some of these special characters like commas will slip into the gzip, I think it's going to be fine, right? There's nothing wrong with that. So, and there's definitely no special characters in the class. So what I can do is basically split by the first comma, right? Separate class and the rest of the stuff and do gzipping on the rest of the stuff. That way, I never have to even parse this shit. I never have to parse the CSV or anything like that. So, sounds like a cool hack. Maybe at some point I'll have to write like a CSV library for C, right? So there's already some CSV libraries for C, like I know that, CSV, C, right, so I'm going to pure C. But all of them, they're like libcsv, like they're proper libraries and shit. Like you're supposed, they have configure scripts and make files and stuff like that. You're supposed, yeah, there you go, right. Look at that. like a configure make file, and it probably produces like a statically linked library. You have to link it and stuff like that. Dude, this is a problem for a single header library. Dude, like, why the fuck does it have to be like that? This is such a simple problem. Like, what? It's just like, no. No, it has to be a proper library, like with a proper documentation. It's just like, it's like, that's what happens when Java developers start to program in C, right? So yeah, that's kind of weird. So is there no STB CSV? I don't even know, honestly. I don't even know. Maybe there is, but so it's not a really difficult thing to implement. It's just like I don't want to do it right now, right? Because what I have to do, I have to just handle the quotes, right? So, and basically escaping within the quotes. So but that doesn't really matter. Okay, guys, so let's go ahead and maybe start working on all of that stuff. So we can start with basically splitting everything by lines, right? So let's introduce something like while content count is greater than 0, right? So we're going to be simply consuming the lines, right? So this is going to be a knob string view. This is going to be the line, and sv chop. Let me actually go there. So a knob sv chop by delimiter. That's the thing I want to have in here, right? That's the thing I want to have. Not the thing I deserve, but the thing I want to have. All right, so, and we're going to be providing the content, and the delimiter is going to be the new line, And let's go ahead and just maybe print all of that stuff. Knob info, and so the usual thing I like to do. So it's not really as, it has to be svfmt, svarg, svarg. Come on, bruv. Line, boom. Let's just go ahead and recompile and run this thing. Okay, segmentation fault. Yes, that is absolutely freaking epic. And surprisingly, yeah, I know why. Right, because I haven't, yeah. So why the fuck did it compile? It's not supposed to compile. Wait, what? Like, I put in a completely incompatible pointer in there, and that's just a warning? In C, I mean, probably. Yeah, I guess, like, I so used to actually, like, very strict warnings from other languages that I sometimes forget that in C, yeah, that could be a thing. Right, so it's kind of funny. So maybe I'm gonna just rename this thing to SB, right, and then I'm gonna construct string view, and I think there should be something like knob sv from parts, where I can do sb items, sb count, and that constructs the content, so that should probably work. There we go. So as you can see, we are just doing that. So it just spits out all of these things. It's pretty slow, but it doesn't really matter, honestly. It doesn't really matter. So we can not even print them, right? So which is going to be extremely fast. One of the things we can do, we can just count lines, maybe lines count, and essentially in here we can say ++1, and we can just do knob log knob info. So s contains lines, right? So this is going to be file path lines count. There we go, lines count. So how quickly is going to count the lines? So it counted the lines relatively quickly, so we can even measure the time. So that's how quickly you can count the lines. Well, I mean, that includes also loading the entire thing into the memory. So we loaded the entire thing into the memory, the entire thing, not stream read it or anything, like just loaded everything into the memory and iterated through the entire thing, counting the amount of lines. That's how quickly you can do that. Which is a little bit too slow, I think. Like, it could be faster. Right, so I think my read entire file is a little bit too slow, right? So that's how fast your computer is. And again, GitHub is incapable of just displaying this shit, right? It can't do that. It's an unsolved problem. Yeah, I see. So my reading file is fucking slow. Right. So essentially, I was so lazy to implement like a proper reading of the entire file that I'm basically reading it in chunks of 32 kilobytes. Right. So the better way would be to actually like measure the size of the file, right? Get the size of the file and allocate in one batch everything and just like read everything. That would be faster. That would be even proper way to do that. Maybe we should do that. How about that? That's actually sounds interesting. And then compare the performance, right? So, because as of right now, right, it's just like 100 megabytes, 100 milliseconds, and that already feels sus. Because I remember reading this entire stuff was way faster. Mmap that shit, but I mean, when I start iterating over mmap, it's going to be basically reading it, right? So I don't know. So I don't think it's going to make it like that much faster. Maybe it will. But at the same time, I also want to keep that implementation cross-platform. And mmap is not cross-platform, unfortunately, right? So if I'm going to start using mmap, that means I'll have to have separate implementation for Windows, right? And yeah, this thing also supposed to compile and work on Windows, right? So if you take a look, so there's a Windows included here. So every time you suggest to do something for Knob, keep in mind this shit must work on Windows. It must work on Windows, right? So I have projects that use Knob and they must compile on Windows. So that's like a hard requirement. Right, people suggest all sorts of cool shit, but does it work on Windows? Right, so if it doesn't work on Windows, that means that for Windows I have to do a separate implementation. If it's a sequential reading, using mmap is not very beneficial and not worth risking portability. Exactly, yeah, I don't think it's worth that. So honestly, there is a little bit of a problem. I ran out of tea. And I would like to make a small break and refill my tea, right? And especially considering that my sleeping schedule is a little bit fucked up, so I'm a little bit sleepy right now. I need extra tea. So I really apologize for that, but I need to make a small break. So let's quickly make a break and we'll be back soon. All right, so let's go ahead and maybe try to speed up this mother flipper. How about that? So read entire file. So how, and I wonder if it will actually speed it up. So interestingly, the way I want to speed it up, I'm gonna just wrap it around in this, macro that will allow me to flip-flop between different implementations of this entire thing. Something like that. So in here, right, in here, I'm supposed to kind of like append, right? So yeah, so in here, I'm literally appending this entire thing. So maybe that's why I decided to implement it the way I implemented it, but that's totally fine. Right, so let's go ahead and just like open the file. So there we go, we opened the file, and then we checked if this file opened successfully. So we also need some sort of a defer section, right? Some sort of a defer section where we're going to be returning all of this stuff. We don't really have a buffer anymore, but we do have a file. So there's also a result variable that is very important because that's the thing that we're returning here, and that's the thing that is set by the return defer. Okay, so, and the first thing we need to do, we need to figure out the size of the file. So the way you figure out the size of the file is by basically using fseek, right? So essentially you set the point, the cursor of the file to the end, right? So like so. So as far as I know, you do that by just setting whence to seek end, right? And it effectively sets the cursor to the end of the file. And of course, this entire operation may fail, right? It may fail, so it may return something like -0. I think, let me double check. So -1, not -0. I mean, it's not floating points. So fseek just returns -1 and sets error no and stuff like that. So we could simply maybe not return defer, but I feel like it is also responsibility of this function to say that something happened, right? So we can do nob log, nob error. So essentially error, well, I mean, it's already error, right? So we can do maybe nob read entire file s, and then another s, error no. So this is going to be path str error no. Right, we can also maybe say fseek, right, something like fseek, so we know at which stage it actually failed. So after we set it to the end, we should try to get the value of the cursor, right? We should try to get the value of the cursor. And since the cursor is at the end, it is going to be equal to the size of the file in bytes, right? And what's interesting is that m is going to be the size, but if it failed, it's going to be negative, right? So we have to check for that as well. Yep. So this is going to be more like a ftell, right? And after we've done that, we have to reset the thing back, right? We have to reset it back like so. We have to reset it back, but we have to do just basically set. This is the second set. You know what? You know what? So there's too much, you know, reading in here. Maybe I could do the logging at the defer section, right? I could do the logging at the defer section somewhere in here, and basically I can do, okay, if result is actually false, only then do the error logging, and we can say something like, right, no read could not read file, could not read file. Maybe without that, could not read file s because of s, right? So, and because of that, we don't really ever have to log anything. We just have to return false. And if an error has happened, it will automatically log everything. I think it's going to be way better, right? It makes the code more compact, right? Which I like, right? Which I kind of like. So, and maybe we can even align all of that by that. And look at this. Does the code look good? Right. For a language without exception, I think it looks okay. I think it looks okay. It's just like an error happens in one of these operations and it short circuits in here, right? And automatically closes everything and stuff like that. I think it's quite good. I think it's quite good. Anyway, right, we can put it in here. So, and essentially we know the size of the file. We know the size of the file, but we need to sort of extend the nob string builder. So the entire thing is supposed to like append this thing in here, but I don't quite remember. Do we have this kind of stuff like nob? So because it was way easier to just append things, right? It was way easier to just append things. So I suppose we can do SB capacity, right? So SB capacity, and simply extend this entire thing. Because you can just have a count, right? So you can have a count and you can say, okay, the new sort of count has to be this, right? So this is more of like a new count. All right, this is a new count. And then you need to check whether it's, you know, fits into the capacity, right? So if new count is greater than SB capacity, you need to extend the capacity, so it becomes the new capacity. How would you extend that? Well, you would take the items, right, and you would reallocate them, right? So realloc with the new capacity, or like new count, and you just reassign this thing like this, right? So this is that, and then you say, okay, this is the capacity now, right? So new count and new capacity. So we sort of like stretched this entire thing. So now everything should fit in there. And now we should be able to read everything in a single swoop, right? So something like fread, but I don't remember how to use this piece of scheiße. So let me copy paste this entire thing. So this is fread, of course, so there's that. So, and how we are supposed to read this entire stuff? So it's going to be items, but we have to read it sort of like at the end. So it's going to be SB plus SB count, right? So, and how many things we want to read in there? Well, we want to read M bytes, right? So this is the size of the single element, and we, so this is a single sort of like a buffer, and we want to read only one of these buffers, right? And we are reading that from F, right? So, and that's basically it. So the thing about fread is that if it errors, it doesn't really return you negative or anything like that, right? So it basically sets F error, right? If F error has happened, right, we just do knob return defer false, and that's basically it. So after that, after we read everything, we should set count to new count, and that is basically it. That is basically the new implementation that just like figures out the size of the file, pre-allocates enough data, and it just like reads everything in a single. You know what I'm talking about, chat? You know what I'm talking about? So that should be cooler. That should be cooler, I think. So. Yeah, and it also acts like it appends to this buffer. So the idea here is the following, right? So you can have knob string builder, something like this, and then you can do knob read entire file, file1.txt into that builder, right? And of course it can fail, right? So it can fail. But then if you do it like this, instead of cleaning up the string builder, it will append the second file into the same builder. It should act like that. So you can concatenate a bunch of files if you want to, like this. And basically you just concatenated 5 files into a single buffer, right? So that's why I was spending some time with this new count, like old count and stuff like that. Right, so does it make sense? Does it make sense? I think it does in fact make sense. Okay, let's try to compile this thing and see like where it's going to fail. Okay, so I forgot that this entire shit is actually a pointer. Thank you so much, C. Very cool. I cannot believe that we still program in this language in 2024. 2024, yeah, today is 2024. Right, but we do. We don't have a better alternative. I know what you're about to say. We don't have a better alternative for C. C occupies a very specific niche, and there's no language today that kind of kicks out C out of that niche. I know what you're about to say. No. C is about simplicity. C is about simplicity. No Rust, no Zeke, no. They're not about simplicity. Pascal was a good candidate to kill C, actually. Right. Pascal was a good candidate to kill C. I don't know. All right. Is it going to compile? It seems to be compiled. So we managed to compile. All right. So yeah. I hope I didn't make any mistakes. So let's just go ahead and yeah. Could not open file for reading, could not read for reading, yeah. So, and let's do KNN. Well, it worked actually. KNN. Yeah, it still works. Okay, let's see if it actually sped it up. Nah. Surprisingly, it didn't. Surprisingly, it didn't. Right, so it doesn't really matter if you like read it in chunks of 32 kilobytes, right? I can actually switch the implementation, right? So let's do knob, right? I'm switching the implementation, right? So I switch the implementation, and yeah, it doesn't matter, surprisingly, right? So it's around 150 and 200, just it fluctuates around that. So I suppose it really doesn't matter. It really doesn't matter. Huh, that's surprising. All right, that's funny. But we're going to be using new implementation. I want you to have this implementation anyway. Right. So I suppose it's more like on average. Though I'm just repeating, it never goes beyond 250. Right, look at that. There is not a single 250 or more. Not a single 250. It's with the new implementation. With the old implementation, right? How quickly we can do 150? Nah. All right, but yeah. So I suppose the difference is negligible. The difference is basically negligible. The difference is basically negligible. Anyway, so let's actually continue doing actual work, right? Let's continue doing actual work. So after that, right, so what we want to do, we want to get the class, right? So we want to do sv chop by delimiter, and we want to chop the line, right? So we're going to be chopping by this thing. So, and in here, we're supposed to have the class, right? So, goddammit, okay. So let's call it class. And the class, I would like to maybe convert that class to a number, knob sv. There was a way to convert to u64, but I don't quite remember. So, is there any way to convert things to sister, append sister? Yeah. Oh yeah, you can do strdupe, you can, yeah, I think we can do sprintf. Right, so in the thing I want to do, I want to do a to I, right, a to I. I swear to God, I remember there was a way to convert to u64, but I think I didn't port that operation from the sv.h. I think I just didn't do that, so I probably have to do a to I. Right, so this is a to I. But to be fair, the class is 1, 2, 3, and 4, aren't they? Yeah, 1, 2, 3, and 4. So that means I can do class item, or maybe even data, that minus 0, and that's the class, isn't it? Basically. So then I can maybe have some sort of like a frequency analyzer classes. Right, so I have 4 of the classes and all of them are 0, so that means I can do something like classes like this plus 1, right, and contains points, let's call them points. And in here I can do for size of I knob less than knob array len. So this is going to be class ses plus plus I, and then we can do print f, knob log knob info. So this is going to be zu, and then we're going to have the amount of those things, right? So this is going to be I, but plus 1 because they counted from 1, starting from 1, and then it's going to be class as I. There we go, and let's actually see how many classes of these things we have. Alright, so this is going to be key and then yep. Oh, that's kind of funny. So we didn't have a single one class. That doesn't make any fucking sense, I swear to God. So yeah, I'm pretty sure that in the data train, at the beginning of the row, we had at least 1 in here. We had at least 1. So that means I did I know what kind of fucky-wacky I did, because I'm supposed to do -1 here as well. Yeah, if I'm going to be doing it like that, right, I also have to do -1, right, because they start from 1. All right, so we have exactly 30,000 of each class, which is kind of funny, isn't it? Which is kind of funny. So we can also check the test, but to do the test, I think we need to start accepting file path as the parameters. So let me quickly do that. Like argv. So we can do const char program, right? So knob shift, I think it's shift args, right? So it's going to be like this, argv. And then in here, what we're going to do, if argc greater, less or equal than 0. So that means you didn't provide enough arguments. So we're going to do nob log error, I said, nob error, usage as input txt, maybe input csv, that is even better. And then we can say error, no input is provided as usual. And then we can exit with non-zero exit code, and there we go. So in here, nob shift, I'm gonna take that, there we go, and here I have file path. So maybe to save on time, I should not rebuild these things, right? So we're only going to be rebuilding this stuff. So program is not used. Okay, so that's fine. Let's use it. Okay, so no input is provided. Let's provide the data train, right? So we have data train CSV. And what about test CSV? Yeah, it's kind of funny how there's equal amount of all classes. It's kind of fun. Okay, it is what it is, and it isn't what it isn't. Sure. So for each class, now we need to compress each individual class. Actually, we need to be able to gzip them, right? To do that, I suppose one of the things we have to do, we have to learn how to use zlib, right? So as far as I know, gzip uses zlib, right? So there's this library, zlib, and it's really easy to start using this thing. It is really easy to start using it because you just want to, I suppose, link with lz, right? So just link with lz, and that's it. So you have the library. Yeah, there we go. So as you can see, so that's basically it. So the main trouble is to how you even use that. Excuse me. I think it's like zlib, and it's not even trivial to use. So it seems to be compiling. So zlib.h. Yeah, there we go. Interface of zlib general purpose compression library. Okay, so let me see, zlib pure C example, zlib compress string pure C example, and let's go to Google. So compress and then decompress a string with zlib. All right. That could be a thing that we actually need in here. Placeholder for the uncompressed. Okay, so placeholder for the compressed deflated. So they call compression deflate and uncompression inflate, which I guess makes sense. Okay, so the thing you're supposed to do, you're supposed to create so-called z-string. Right, so you assign a bunch of things like z-alloc, z-free, opaque. So I suppose it has something to, so you can provide your custom allocator in here. Right, so, and then you just like define what's available and then some other stuff, and it just compresses this thing. So then you do deflate init with the best compression, then you deflate with z-finish, and then you do deflate end. And I suppose in B, you're going to have the compressed thing. So we should give it a try. That's kind of a weird thing, but yeah, let's give it a try. So KNN, deflate SV. So I think that's a good idea generally. I think that's a good idea. So it's going to be a knob string view, right? Knob string view, and you're going to be accepting SV here as well. I think that makes sense. So where are we going to be allocating stuff for the compressed one? We can allocate that in a temporary buffer, right? So tempalog, not tempalog. So essentially we can just pre-allocate stuff in there. So sounds good, sounds Gucci, sounds Tamaguchi. And as soon as we manage to do that, so using this thing should be relatively straightforward, hopefully. I don't know, we'll see. So zstream, let's just allocate this thing in here. Shouldn't we actually, like, you know, fill it with 0? I think that would make sense. And that would, like, yeah, if you just allocate it like that, you don't have to do these kind of things, right? So because they're automatically going to be 0, right? So I think that's worth it. I would like to take a look at the definition of zstream. Right, so here is the zstream. There's a lot of shit in here. Look at that. So used to allocate the internal state, used to free the internal state. So if I put void, anyway. So private data object passed to 0. Okay, so that's kind of funny. So you can just use like a custom allocator and stuff like that. That's kind of funny. All right, so that means I don't have to do that, but what I have to do in here, right, I have to pre-allocate some stuff. So the length, size of input, string plus terminator, but we don't really have a terminator. That's what's funny about this kind of thing. We just have a count. Right, maybe I have to cast this thing in here, but I mean, it feels a bit unnecessary. Input characters is just that, right? So this is the data. What's going to be the output? Like, and how do we know that the output is going to be smaller than the input? How do we know that? I'm not really 100% sure, honestly. Can it just allocate it for us? Like, look, we are providing allocators, right? We're providing allocators. Can it just like allocate the output for us? Next output byte will go here. Remaining free space at the next out. Total number of bytes output so far. So yeah. Available in. So it's sort of like this API is sort of designed to like sort of stream the entire thing, right? So it's designed to stream. So this is rather complicated, actually. It's rather complicated. So what I can try to do, I can try to just like do knob temp allocate, and I'm gonna just allocate twice as much as I have in there, right? So this is gonna be like the output, like this. Output char array. All right, so the size is going to be basically sv count multiplied by 2, right? So this is the output, and that's the output, I suppose. Bit bizarre. If it's compression, shouldn't it by definition be smaller than the original? I don't know, honestly, right? So sometimes you have small files, right? Very small files, like, I don't know, something like echo hello txt, right? So, and it's a very small file, like 6 bytes, and then you try to gzip this file, right? So you try to gzip and you end up with 36, but you can argue that maybe it's some metadata of the gzip format. I don't really know, right? So it's just like, why exactly it became bigger? Like, is that because of how gzip works on a very small data? Or is that because, like, I don't know, like, why? So should we also account for that? How do we account for that? Like, why do we even have to account for that if maybe we can ask the library to allocate all of that stuff? Like, I don't know, like, how do I handle that? I have no idea, right? So that's why I just allocated twice as much, hoping for the best. So that's what I'm doing. Just hoping for the best, because there's so many unknown like parts that I can't predict. So I probably need to read documentation, but it will take some time. I don't freaking know. Anyways, so we want to do deflate, and then yeah, then we'll do this kind of thing. And so they're doing a little bit of a sus thing in here. They're using strlen for b, And that doesn't look good. That doesn't look good. Yeah, so people even mentioned that. So they suggest to use total out. They basically suggest to use total out. And this is something that we can use. We can just do knob sv, from parts. So this is the output, and then we can do z stream total out. Right, so total out, something like this. So we can try to do it like that, right? So we can try to do it like that. And again, it would be super nice if I could tell zlib, just use the allocator that I provided to you and just like allocate all of that shit for me. Right, just like why do I have to do that? Available remain space at the next output. So yeah. Anyways, so anyways. So maybe, yeah. How can we even test that? How can we even test that? We can try to take one of the lines, right? So we can start, let's limit like how many lines we handle in here. Let's try to handle maybe first 10 of them, right? So first 10 of them. So we have a class in here. We have a class in here, and maybe we can do class index, and we can put that stuff in here. So line count, I think it could be useful actually. It could be useful. And funnily enough, instead of I, we could have used line count. Right, so we could have just used line count, lines count. So we didn't have to do plus plus at the bottom and here. So we have a limitation, and we also count the amount of lines and stuff like that. So, okay, we have a class, right? So we have not even, yeah, so this is the class, and within the line, we have the data that we want to compress. So maybe we want to print some interesting stuff in here, right? So it's going to be knob info. We're going to say class. So this is ZU. Then uncompressed len is going to be one thing, and then compressed len is going to be the second thing. So here I'm going to just provide the class like so. So uncompressed length is going to be line count, and then so what was the, I think it was deflate SV, right? So deflate SV, we provide the line and we take account of that. So, and then at the end we can simply do knob temp reset, which deallocates the allocation that we did inside in here, right? It will automatically deallocate this entire thing. So, and yeah, so we're gonna just handle first like 10 lines and see how much it compresses their descriptions plus titles. So maybe we can even print the line count, right, lines count, and let's just go ahead and try to run this entire thing. Something is really weird going on, right? So let's go ahead and do that. So there's some stuff in here, z stream. So this is the def stream. Okay, so so uncompressed len went completely haywire. All right, that's it. And okay, so something is definitely wrong in here. So let me see. Okay, so lines count, class, uncompressed. That is bizarre. Straight up. That is straight up bizarre. So while line 1, 2, 3, 4, 1, 2, 3, 4, all of them are ZUs, so I don't really know. Very effective compression indeed. I do agree with that. Very effective compression. So yep. So line, does it fuck up something? I literally don't understand why it is like that. So because I just did chop by and class worked perfectly. So knob info zu line count. It's totally fine. It is in fact totally fine. Okay. So if we don't compress this in, okay, there's a new line in here, so maybe the new line actually fucks it up. Excuse me. So let's remove that stuff. Yeah, so what the fuck is going on in here? What the fuck is going on? That is weird. Something with the printer specifically. I feel like there's something specifically with the printer. So if we just do line count, it's totally fine. Okay, so what about class index? So class index. Oh, I was using class in here, so that's what, okay. I should have used class index. Okay, so this is the problem with the custom printers like that. That's the problem with the custom printers. And on top of that, like, what the fuck is this shit? Well, yeah. So one of the things we have to do, actually, we have to skip the first line. We have to skip the first line if because the first line, if we take a look at the training, right, it contains the header, right? So one of the things we can do, lines count equals 0, just continue, right? So we got the first line, right? If the first line, just ignore the header. Okay, so this is the class, and this is the actual class index, and so on and so forth. So class index like this. So I see what was going on, right? So lines count. All right. So we have uncompressed length and stuff like that. So everything seems to be okie dokie. Compressed len is going to be zu. So deflate sv. Deflate sv. I set line count. How many things we can even compress in here? And there is a little bit of a compression if you look at that. So for example, we can say how much compression. How do you compute compression, by the way? How do you compute compression? You divide compressed one on uncompressed one. What is the compression rate? Compression rate. Definition. What's the definition? Don't remember. Data compression ratio is just like a compressed over uncompressed. And okay, so uncompressed size, compressed size. Okay. So we have a line. After that, we can have knob string view. Compressed line, and we can just take that. So here's the compressed line. All right, compression ratio, it's gonna be F. So we take uncompressed, so just the line, but that has to be flowed, and we divide it by compressed one. So let's see. So, and yeah, uncompressed size. So I think we're most interested in saving space, right? So because of that, we probably want to swap this value and do -1 and say saved space, because that's interesting. Right, so 20% of the save space usually, right, on average. So it does compress some stuff. It does in fact compress some stuff. It's pretty cool. It does in fact compress some stuff. Mother flipping stuff. All right, so, and usually the result is smaller than the other thing, right? So we can take a look at maybe thousands of them. Yep. So what I'm interested in is how quickly it can compress like all of them. How much time does it take to iterate through all of them? Pretty fast. Pretty fast. I really like that. I actually ironically like that. So, and this is only test. Okay, so it took almost 200 milliseconds to go through the test file, though. Test file. What about training? Because to classify a single test sample, we have to iterate through all of the 120 and compute the normalized distance. On top of that, we'll have to then sort by that normalized distance and do the like k or something. So yeah. So let's go ahead and do the training. Training CSV. That was fast as well, actually. What the hell? Oh wait, okay. That's easy. It's thousands of them. This is because it's thousands of them. It's easy. Oof. Okay, so let's actually do 10 thousands. So it may slow. Okay, it starts to getting slower. So it's just like 1 second. Oof. Okay, so let's remove the limit. Let's remove the limit and like see how much time it will take to compute all that stuff. So I suppose it's going to be around maybe a minute, half a minute to classify a single thing. Interesting. So it's taking some time. Yeah, okay, so almost 20 seconds. Almost 20 seconds to iterate through each individual thing. But what's interesting is that to classify a single sample, we'll have to also do several compressions. Several compressions. So yeah, that's rather interesting. Okay. I kind of want to do another break because I need to refill my cup of tea again, right? Because I literally ran out of tea again. So let's make another small break, right? So all right. So what we want to do? Do we want to actually maybe collect all of these things into sort of like a maybe separate collection, right? So because we need to keep both training set and the testing set in memory, right? So we need to keep them both in there. So maybe we could have like a structure where we could have the class, right? So this is going to be the class and the data, right? So maybe the text, let's call it text. So, and that's gonna be a sample. How about that? That's a good way to call it, I think. That's a good way to call it. And we also probably need the samples, right? Because we're gonna be collecting them, right, into a dynamic array, because then we'll have to sort that thing. So yeah, that's going to be interesting. So this is going to be a bunch of samples. So the sample is going to be items, and then we have a count of these things, and we have capacity of these things, right? So we have this kind of stuff. All right, so and then as we parse all of that stuff, all right, so for now I'm not going to be doing compressing or anything. I'm going to be collecting the samples. Right, I might as well just do samples, like this, and knob da append. I'm appending to samples, and what I'm appending in there is sample class index, and then text line. Right, so we're just collecting those samples. Maybe we could even factor out reading and parsing the file, the CSV file, into a separate function. So we could say something like read samples from file. And of course, reading stuff from file can fail. So what we want to do ultimately, we want to maybe return an error. But I mean, yeah, it would be better to actually split that step into two. So let's actually do something like parse samples, right? So we're parsing the samples, but what we're doing here, we're actually passing the content, right? So we're passing the content. So that's basically what we want to do. So in here, we are gonna do something like this. Yesu. I'm gonna just move the stuff in here, and then we're basically parsing the sample. So we have a content, and maybe I'm gonna even do it like that. I'm gonna just literally inline this entire thing. And the samples, I have the train samples, right? So this is the train. And honestly, I think I need to start accepting two files in here, right? So train CSV and test CSV, right? So we're gonna accept both of them because we need to read both of them into the memory and parse them, right? And we're going to be iterating the test samples and comparing them to the training samples to figure out the tests category, right? So to figure out the test category, I think it's going to be interesting. So you know what I forgot to do? I forgot to actually have classes somewhere, the names for the classes. So data classes. It would be kind of nice to maybe have some sort of an array of those things. Right, maybe even as strings. Maybe even as strings. You know, I've got an idea. I've got a freaking idea. What if we just like literally go to AG News, right? I hope my government is not gonna fucking kill me for showing some news, some Western news. I'm joking. They don't give a shit about what's going on in English. Where's the AG News? What was the website? Why it doesn't show me that? Like, it's so bizarre. Wait, I'm pretty sure AG News was some sort of a website, wasn't it? I think it was a website. Maybe I'm imagining it. I only know AP News. Associated AP News. Okay. Why is it so? Oh my god, my laptop is fucking dead. Huh. All right. We can actually, yeah. So we can try to take one of the titles and descriptions from here, for instance. Right, and try to classify that given the existing dataset. That would have been interesting. That would have been interesting. And to be fair, this amount of classes is actually kind of limited, in my opinion. Right, so we'll see. Anyways, so for some reason, like in 2024, like in the modern years, it became kind of difficult to like find anything on the internet. It's just like everything is so fucking filtered, and it's just like it feels very small in internet. It's just like anyway. So class names. The internet feels increasingly smaller and smaller and smaller. You're being put into this small little cage, into this bubble. It's very difficult to escape. So AG News is Antonio. I think I confused it with AP News. Right, I think I confused it with AP News. I think that's what it is. All right, so we have this kind of stuff. So I want to say train path, right? So this is a train path. So, and in here we can say train buffer, or maybe train content. Right, train content. So this is the train content, and this is the train samples. Right? Train samples. So then afterwards we can kind of repeat train sample, train file, no train files is provided. So in here we can say no test file is provided, and we can kind of replace train with test in here. Right, and there we go. We have two things: train samples and test samples. Right, and one of the things we can do, we can just try to go through each individual test sample and try to classify this thing. So it would be nice to even have a function that returns like classify sample. All right, so we can supply samples in here, like a train sample, and then we could have like a text, just simply classify this text. You know what I mean? Like to do not implemented. Right, and that will basically go through each individual thing, compute the NDC, normalized distance, normalized NCD, normalized compressed distance, and then do k nearest neighbor, right? So, and afterwards, right, to do the k nearest neighbor, you need another actually struct, right? You need another struct which basically contains the distance, right? And I presume it's going to be float because we're going to be doing divisions and stuff like that. And it also has a class, right? So we can call it normalized NCD, compressed distance. Is it how it's called? I think that's normalized compressed distance, right? So, and you're gonna have a bunch of those, right? So because we're also going to be sorting by them, so that's kind of important. NCDs nuts. Oh. So this is gonna be items, and then we're gonna have count, and then we're gonna have capacity, and there we go. We have NCDs. So, and yeah. That's going to be very, very important, very, very important. But I mean, I was just slapping the code without even trying to compile any of the shit, so it probably doesn't compile in the slightest. So let's go to the compilation errors. So what do we have in here? Nope. Passes 2 arguments, but takes 2. So is nobda append? Oh yeah, it is in fact actually a macro, so that's understandable. So this is a nob string view. What else do we have in here? So some of these things are unused. I mean, it's not that big of a deal. So let's just mark this shit as unused. What else do we have in here? So this is a file path. This is a train path and train content. What else do we have in here? Train content. There should be like a function to convert string builder into string view. There should be something like that, but I don't have that yet. So I don't have that yet. So test content, there we go. So what else do we have in here? So test samples and unused, that is unused. What else do we have in here? So in here we have just a control that we have to return it like that. So this is the samples. Boom. What else do we have in here? Okay, so that's cool. We can try to now provide, we didn't provide the test. Let's provide the tests. And okay, so everything was loaded and parsed, right? So we loaded and parsed both of the files, which is super cool. So the next thing we can try to do, we can try to classify maybe one of the texts, right? So that would be interesting. So essentially we provide the train, but the text that we want to provide in here is going to be essentially test samples. Let's just take the first thing from the test sample. Right, and a single sample is what? It contains the text, right? So let's maybe even put that into a separate sort of sample in here. So we're just classifying, right, a predicted class, right? So this is a predicted class, and we can try to print all of that stuff, right? So let's take a look at knob info text. So we have text like this, svfmt, arg, so sample text, and we can do knob log, knob info, predicted class. It's going to be like this. It's going to be even s. We have class names, right? So class, what was the class names? Yeah, there we go. Class names, class names. So this is the predicted class, and then actual class. Actual class is going to be sample class, something like this. There we go. So train samples. All right. So assertion failed. Yeah. So we need to finally implement the classify sample. That's what we need to do. Predicated. Yeah. Predicated. Huh. That's interesting. It's like one character away. Predicated. All right, so the next thing we need to do, we need to actually keep track of these NCDs, right? We need to keep track of them. Since we're going to be iterating through the training set and finding the distance, we need to keep collecting all of that stuff. We need to keep collecting. Maybe, by the way, we can have a function ncd knob string view a, knob string view b. Right, so let's actually go ahead and compute that. So basically encode this formula. So we want to have cx, which is basically, we need to compress this entire thing, right? So it's going to be, maybe we can even do deflate sv, right? So we do deflate sv a, and it's going to be simply count and y. Let's do it like this. So we have these things. Right, but that's not enough also. Right, so we need to concatenate two things. So maybe we also need to have something like cab, and it's going to be deflate a b, like so. But now we need to construct a and b. Should be pretty straightforward, I think. I think it should be pretty straightforward, because one of the things we can do knob temp as printf, and here we can do svfmt, and then maybe we can even put, well, I mean, yeah, we can just concatenate it like that, svarg a and svarg b, and there we go. We've got basically a b, but it's going to be C string, right? So as far as I know, there was a way for me to construct a string view out of that. So from sister, yeah, so it's relatively easy to do so. So that creates knob string view AB. So that's what it creates. And now I have all of these things in here. So that is cool. That is cool. So, and now I can do CAB. CAB, and I need to subtract minimum, right? So maybe I can do something like float mn CA. If minimum is greater than CB, minimum becomes CB. So that's basically the first thing. And with a maximum, CA maximum less, like this. So now I have minimum and maximum, and I can just subtract minimum, right, and divide by the maximum, and that's basically the formula that we have in here. Right, so all of that does a bunch of allocations in the temporary buffer, but that's fine because we're going to be cleaning up that buffer as we go. Right, so that is very, very cool. So let's go through the training set. So this is going to be like this. Less than train, so it's going to be count plus I, and so let's just do NDC on those things. Right, so we're gonna do train items I, and then the text, right? So, and that gives us the distance. That gives us the distance, and as soon as we can compute the distance, we don't really care about the temporary data that we put in there. So we can do temp reset, right? And it's very important. Otherwise, all of these allocations are gonna, like, you know, overflow our temporary buffer. So we have a distance, and the class is the class of these things. So nob da append, we're appending to NCDs, and so NCD is basically distance class train items class, like so. There we go. And interestingly, that's it, right? So we computed all of the distances and stuff like that. So the next thing we have to do, we have to sort them. Before we do them, by the way, we can try to maybe print them. That would be interesting, or at least print like first 10. So maybe top 5, top 5. So top 5 NCDs. Sorry, memes permanently damaged my brain. I really apologize for that. Okay, so we're gonna do like 5 plus I, and also I less than NCDs count, and let's just like print them. Nob log. Right, class. So this is the class, and this is distance. Right, so it's gonna be F. NCDs items. This is class. NCDs items I distance. Right. So, and this is like a predicted class, not predicted, actual class, blah blah blah. But that's going to be printed by the classify sample. Right. So as of right now, I'm going to put 69 because it's a temporary thing. I might as well assert that this thing is not implemented yet. Like so, to do not implemented. Let's try to run this entire thing and go through the compilation errors, of course. What else do we have in here? Items. So this is I, incompatible type 1 of NCD. So this is bizarre, right? So because it's supposed to be string view. All right, so that means I'm supposed to put text in here. That makes sense. What else do we have in here? I forgot semicolon. Is that what you want? That's probably nob info. Boom. What else do we have? Ooh, it's okay. So it's going to be around 70 seconds. So the problem with this thing is that to classify a single sample, we need to wait 17 seconds. So that's kind of the problem, at least on my laptop while I'm also streaming. Right, but we're not even parallelizing anything, right? We're not utilizing the power of multi-threading. So maybe we can cut down the time. Is it going to be cut in 4, right? If I do something like 17 divided by 4, right? So 4 seconds, probably not. Actually, it will take more time because we're doing at least 3 gzips in here. We're doing at least 3 gzips. So, yep. I wonder how much time it will take. It will take like a more than... Oh, right. So that's cool. So it took like a minute to classify a single thing. Right. So, but this is a very naive approach. No parallelization. And we're doing that only while I'm streaming. On a 10-year-old laptop. So yeah, so that's, I guess that's expected. Like I didn't put any effort into optimizing this entire thing. So maybe I will. We'll see how it will go. Okay, so the next thing we need to do, right? So we've got some distances and stuff like that, right? So that's totally fine. That is totally fine. So, and 1 minute is Okay, right, so we can wait for 1 minute in like on a stream, so this is bearable at least. Now, what I want to do, I want to basically sort this entire stuff, right? So we need to sort NCDs by the distance, right? So because we need to pick the k closest ones. And what's going to be the k though, right? So that's a very interesting question. So what's the k you usually pick? Did they even mention what k they used? It's going to be like 10, 100. So we have a lot of things. Maybe something like 1000, k 1000 could be a thing. From the brief scrolling through the page, it's kind of not obvious what kind of k do they use. So it is really not obvious. So I don't know. Okay, so I suppose we're gonna pick something. Q sort. So let's do the sorting. So the base, we're doing NCDs items. So the amount of items we have is NCDs count, and the size of a single item is basically NCD items size of, right? So that's size of. And we need to have a function that compares NCDs, right? So let's have something like compare NCDs. And maybe we're gonna take it like that. All right. So that's the function we need. That's the function. That's a really weird. So size void. Okay. As far as I know, they're just like void pointers, right? So this is going to be A, this is going to be B, and so we just return an integer. And so we need to cast them to NCD, right? And A, and B, and we want to just compare those things. So if an A distance is less than an B distance, right? So it has to be less than 0, so that means it's going to be -1. Right, if an A distance greater than an B distance is going to be 1, otherwise it's going to be 0. It's a very dumb approach, but yeah, so that should be fine. So, and we just sorted this entire stuff, right? So we just sorted this entire stuff, and the question is, what's going to be the k, right? So what's going to be the actual k in here? So since we have so many samples in here, maybe it makes sense to actually pick like 1000 of them. 1000. What do you guys think? K is equal to the number of classes? No, it shouldn't be like that. We have only 4 classes and 4. Can you pre-compute deflated length of the training and the test data and save it to the file? I can, but this is not the only thing that we need. We also need deflated length of their concatenation. So that means size of the training set multiplied by the size of the test set, which makes it even bigger. So, I mean, I have to pre-compute that off screen on a separate computer, if you know what I mean. So, right. So, okay, class, we need to have like a classes frequencies. So we can do that, but that's not for the stream. That's why I don't do that right now. Class frec. So it's going to be 4, and this is going to be like a 0. All right, so let's do size t less than NCDs count plus I, and also less than k, something like this. And we can do class frequency. This frequency. NCDs items I class +1. Right, so we take the class of this thing, we increment the frequency, and now we need to find the maximum among them. We need to find the maximum among them, and that's going to be the classified thing. We might as well even pass k as a parameter. Right, so it could be literally a parameter, because why not? All right, so how can I even do that? So class predicted class is going to be -1 for now, and I'm going to just iterate the amount of classes that we have. Ideally, I would like to maybe even have class, yeah, maybe knob array length class names, so we allocate as many as we have like names for these classes, and we're going to be iterating as many as we have those names, right? So I think that makes sense. Right, if predicted class, why do we have predicted class here as well? Where did I, okay, that's unacceptable, honestly. Why does it start with C? It's not supposed to start with C. Okay. Predicted class. If predicted class is less than 0, right? So that means we are right away are doing predicted class equal to I, which means that I could have just like done it like that. Right. So then I can do class frequency, predicted class. If it's less than class frequency of I, then I just assign. Okay, so that was easier than expected, because we have to work on a level of indices. So that's it. That's the whole algorithm. Should be at least. That should be at least the whole algorithm. All right. So that's pretty cool, game. Okay, let's give it a try. Let's go at least through the compilation errors. I think they are going to be rather interesting. Okay, so what don't you like? Const. Okay, sure. I can mark them as const too. Not that big of a deal. Of course, I should not forget to do it like that. Of course. What else? Compare NCDs and declare. Really? Did I call it compare with E? You probably can't see that, but it was called like that, and I just added E in here. This probably was the... Wait, how did I call that? Okay. Compare NCDs. So that's what I should have called. Classify example. So let's put 1000 in here. Let's put 1 down. Okay, so we have a thing that compiled. Right, so we have a thing that compiled. So let's go ahead and just try to run it on the first sample from the test and see how it goes. So yeah, so we also have like class names and stuff like that. It would be funny if it fails. It would be really, really funny if it fails. Maybe it would make sense to print the progress of how many samples we processed. I think that's a good idea, actually. So classifying sample. So we can do maybe printf /r. All right, so maybe, yeah, /r samples. Classifying zu I train count, something like that, and afterwards we can just do something like this. I think that's a good idea. Ooh, it's very flickery, so that means it would be better if we just went there, and did all of that soon in there. There we go. That's very funny. Why is it flickering this much? It's kind of funny, but I mean, it does the job. You can kind of see. /r is supposed to basically go to the beginning, right? So I don't know what's up with this kind of shit, but yeah, we can at least see. So it's basically almost halfway through. Now it is halfway through, so another 60,000 of them. Another 60,000 of them, and we're about to predict. We're about to predict the class. So I think we do a little bit too much of the useless separation. I think we don't have to recompute. Yeah, so it failed in the first one instantly. It's kind of fun. Right, so maybe. Okay, so how can we speed it up? We don't have to compute this thing all the time, honestly. Right. We don't have to compute it because we can pre-compute it once, right? Because it is the same all the time, right? It is the same all the time. So what I'm thinking is that we can accept CB in here, like a parameter, and then here I can simply pre-compute CB as the text. We still have to pass text in here because we need to pre-compute CAB, right, concatenation of this thing, and that's a separate thing, but that may speed up the whole thing a little bit, right? So because we're doing one less deflate, right? So we're kind of doing a redundant deflate all the time, so which is not particularly bueno in my opinion, right? So now I think it's a little bit faster, but who knows? It's kind of hard to tell. Well, it will be visible on the whole time, right? And the why it didn't predict, maybe because the k is too big. I think the k is just too big. So we can set the k to 100. So almost there, almost there. Okay, so it's actually faster, right? So as you can see, this is what before and this is now business world. So I think the k is too big. I think the k is too big. How about we reduce k to 100? How about that? So yeah. So if this is 1 minute, right? So if I just parallelize that in 4. Is it going to be really 15 seconds? Though when I'm not streaming, I think it's going to be faster, right? So it's definitely going to be faster. And also, as somebody said, we can pre-compute the like a compressed distances for the training set, right? So, and then the only thing that we'll have to compute is the concatenation, like a cab. In here, so we can pre-compute this thing as well. So this thing is pre-computed there, and another thing is pre-computed there. So that may save a little bit of time as well. Still, with the k, it still doesn't really predict well, right? It still doesn't really predict well. What about another sample, right? So still, do they say what kind of k do they use? Do they say what kind of k? It's not obvious, right? It's probably mentioned somewhere within the text or so, but what's the k? What's the actual k? Kind of weird. All right, so we can try to do a different sample. Let's try a different sample. So only mention of k. For all zero training methods, the only hyperparameter is k. We set k to equal for all the methods on all the data sets, and we report the maximum possible accuracy getting from the really 2. how 2 is sufficient? So, okay. Look, I also want to double check. Okay, thank you for so let me do Control F so to make sure that it's actually there. For all training for all 0 training methods, the only hyperparameter is k, all the methods, and we report the maximum possible accuracy getting from the experiments of each. Okay. All right, so for the second parameter, it predicted correctly, right? So predicted class and actual class. But we're using K100. All right, so let's actually set it to 2. Okay, sure. And let's see the first sample. Maybe it's just the first sample not being good enough, right? If you know what I mean. It's kind of hard for me to believe that K of 2 is enough to accurately predict the class. It's kind of bizarre to me. I'm also a little bit worried that maybe I made a mistake somewhere, right, during my computation, but everything I did so far makes sense, right? So everything I did so far makes sense. Just bad training data, maybe. Yeah, so I think it's that specific sample is kind of mad. So yeah, one of the things I want to do, I want to go to AP News and just grab a title from there and see if it can classify just a random title from AP News. Okay, so this is the Republicans. So this is just like elections. Okay, business, right? So can you classify business? Investigation to focus on missing bolts. Okay. So we have this thing, which looks like the thing we may care about. Right, so so does it have a dot? So this is the title, and this is some other thing. So this is the text that we may want to try to predict. So predicted class. So classify sample. Sample text. So knob sv from sister. So this is going to be text, and we get class. Knob log. Knob info. We're going to do text. Right. It's just text, and then class names. All right, so let's recompile this entire thing. Size t class. So you want me to have semicolon in here? Sure. Test samples, we don't care about them. Okay, let's go. Let's try to predict that specific text. So it's supposed to be business, right? So it's supposed to be business. Class world. All right, so we classified it as world, not as business though. And to be fair, I would personally not classify it as business as well. So yeah, so something like sports could have been actually something like clear. Right, so there was such words as coach and losing seasons and everything. So that looks like something that could be classified as sports. Right, so let's try to see if we can classify this thing. So what does it look like? So there's a new line in here, so let's get rid of the new line. Let's try to classify that. They used bzip too, really? But I mean, I just use zlib. All right, so though, right, so they're literally using the external tool, but I mean, they're just using Python, and what Python exactly use, right? So If I understand correctly, what they just use this thing, right? And how does this thing work? Does it call to an external tool, or does it do something else? So yeah. How can we replicate that in pure C? Because in pure C we just like call to zlib, right? So the way we compress this shit is just this. I'm not sure how good of a way to compress it this is. Well, I mean, to be fair, like it classified the previous title more or less correctly. Investigation into why panel blew off of a Boeing MAX 9 jet focuses on missing bolts. Federal regulators are extended to ground. I wouldn't classify it as business either, honestly. I wouldn't classify it as business either. So the fact that it classified it as a word kind of makes sense to me. So yeah, so I would expect, let's actually find something in business that is related to money. So scammers, for instance. Down, but not fast enough to meet Biden's goals. Stock market. This is a good one. Okay. Stock market, Asian shares. Oof. Did I accidentally? What the fuck is going on? Can I just select this thing? Right. So I hope they don't. The news website like to embed like you know, hidden things. Where is the description? Does it have a description? We can include, so the first paragraph, so to speak, as a description. So this looks like a solid business. This looks like a solid business. Stock market, shares, 2%, shares, session, Wall Street, straight up. This is a good like business, I think. This is a very good business. So, and hopefully that will classify it as business. Okay. That's fun. I really like that. Okay, even though it dog shit slow. This is the most business imaginable, exactly. Ran out of tea again. God damn. Ouch. 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 Holy shit. This shit works. This fucking unironically works. What the fuck? Like, I mean, it correctly so far. Like, this is out of the dataset. We're picking shit out of the dataset and it fucking works. What the fuck? This is so cool. This is amazing. Holy shit. Okay. So what are the class names we have? Class names. Business SciTech. Okay, let's actually find SciTech. And let's actually read the titles and make sure that they're actually SciTech. NASA, okay, NASA postponed landing, blah, blah, blah. Yes. It's actually kind of sad. Why did they postpone, by the way? I kind of read this news, I think today, and I didn't look into that. So what exactly happened? Is it something with... It's actually kind of bad. It's kind of sad. Right. Solar panels not working. I see. Alrighty. Okay. So So this should be SciTech, hopefully. Give it something that is misspelled. That would be interesting, actually. But I'm not sure if it matters that much. Because we have a lot of training samples, and gzip might be very smart. I don't think it matters that much, honestly. I think it matters that much. And the fact that k equal 2 is also enough. It's just like, I would expect k to be like at least 100. But I'm not really proficient in this kind of algorithm and this kind of like methods and stuff like that. So, fuck. So we had a fluke. We had a little bit of a fluke. It fucked up. Fucked up. Maybe it just doesn't have enough data. We don't have enough data, guys. Guys, we don't have enough data. Let's actually give it more data. So maybe. All right, let's pick a different title. We need to two companies will attempt the first. So why is that sports? It's so far off. So moon landing. This one looks good. First video, deep space. Okay, so that looks very sci-techy, if you know what I mean. Right. So there are even cats in here. I really like that. Const char text. Lasers, deep space, stars, video, laser, deep space. So yeah, that could be a thing. So we're having a hard time classifying SciTech, apparently. We have a little bit of a hard time classifying SciTech. I bet the word. Place your bets, chat. Place your bets. So Twitch has like these sort of prediction things. We could have actually started predictions and stuff. I don't know how to use that. I don't know how to Twitch. I'm sorry. I don't know how to Twitch. I'm not engaging enough. Dead streamer. Literally dead streamer. Okay, so world. All right, so that was somebody actually predicted world, right? Somebody actually predicted world. Maybe something about computers could be, you know, predicted properly. So is there any website on like computer news? Computer news. Oh my god, why is it so slow? Computer news. So let's try to predict computer news. So tech news, computer world. Wired. Startup firm creates to cache. Okay, so let me try to. So this must be tech. This must be tech. Const char text. Mistakes. All right. So we also have some Unicode, but maybe that's fine. Maybe that's fine. Okay, this is probably gonna be the last one. After that one, I'm gonna call it a day. So we also have AI in here. I don't know how much AI we have in AG News. Fuck. Okay. Oh, okay. I know what is fucked it up. I know what fucked it up. Startup firm. Okay, SciTech is a very difficult category to predict, right? It's a very difficult category to predict. So yeah. We can, okay, so let me see. So what do we have? So SciTech is basically 4. We can go into the data, test, and all right, so we can just pick this thing and see how well does it predict. So it's supposed to be SciTech. Right, so we have that. Might as well just get rid of that. Scheiße. So yeah, this one is like very easy to explain because I think it picked up on startup. Right, startup is probably business, so business is closer. Business turned out to be closer. How is that SciTech? Spam suspension, shares, percent, mobile phone network. Yeah. Bet business, but I mean it's from the test data. This is from the test data, so it should predict. So maybe the training just doesn't have enough, you know, data on SciTech. Maybe that's the problem in here. Maybe that's the problem. Come on, you can do that. It's almost there. It's almost there. I'm about to dab. About to dab on all of the doubters. Fuck. It's business. It's business. Okay, so the conclusion is SciTech is very vague term. It is very vague term. It's really difficult to predict, right? So far something like sport is way easier to predict. So let's take a look at the sport. But though, so the problem here is that the computation is also very slow. If it was a little bit faster, we could have actually iterated a little bit quicker. It would be kind of nice to iterate through all of the like test samples and see the percentage of how accurately it predicts the test samples. Right. So, and this one is supposed to be the sports, right? So coach, right? So seasons and stuff like that. So that's gonna be the thing. The data is biased, Copium. Yeah, exactly. The data is just biased. All right, come on, we're almost computed. Yo, and it is sports. Look at that. It correctly predicted that. It is conscious. Holy fucking shit, guys. It is conscious. It understands the text. The only way it could have predicted that class is if only it understood it. That's the only way it can predict the class. There's no other way. It understands it. It has conscious. Holy fuck. Give me $1 billion. Microsoft, give me $1 billion. Holy shit. It's conscious. It's fucking conscious. All right, so that was fun. So yeah, we can spend some time maybe speeding it up. Maybe I'll spend some time off screen. We'll see, but yeah. That's a fun little paper. Right, obviously what they did, they evaluated on shit ton of different kind of data sets, and apparently it worked. It worked really well. So, and that thing performed on par with large language models, which tells you the accuracy of large language models. If this shit performed on par with large language models, I'm very pessimistic, honestly, right? So anyway, I guess that's it for today. Thanks everyone who's watching right now. I really appreciate it. Have a good one, and I see you all on the next recreational programming session with Mr. Azuzin. I love you. Mwah.